Hello, welcome, and today we are going to learn about least common multiples, which is also known as the smallest or lowest common multiple. In short, it is usually referred to as the LCM. This curriculum is designed for 5th grade or higher, and it assumes that you already know how to multiply, divide, and factor numbers. If you don't know how to do them, I strongly recommend that you learn those concepts first before you take this lesson. In this lesson, I'll be going over the definition of the least common multiple and teach you how to find it using two different methods. Lastly, I'll be covering some reviews and examples along the way. I'll try to make it as intuitive as possible so you can follow the lesson even if you forgot or never heard of some of the concepts that I'll be using. I'll be also giving you a lot of tips, so just be careful watching it. So let's get into it. What is the least common multiple? You can guess that it is something that is related to multiples, and since it says least and common, you might also guess that it is not just talking about one multiple. And you're right, it is comparing two or more. But before we get into that, let's talk about a multiple first. What is a multiple? By definition, it is a product of a number times another number. Let's look at some examples. As you know, the multiple of 4 goes on like this. 4 times 1 equals 4, 4 times 2, 8, 4 times 3, 12, 4 times 4, 16, and so on. What about the multiple of 5? It goes like 5, 10, 15, 20, 25, right? But do you notice anything? On the list, 20 appears on both multiples. And here you say 20 is the common multiple of 4 and 5. Okay, so what is a common multiple? It is a number that is shared between two or more lists of multiples. Okay, let me give you another example so that you can try it out. Bringing back the multiples of 4 and 5, let's add the multiple of 6, which goes like 6, 12, 18, 24, and 30. Now I'll give you about 5 seconds to answer my question. If you need more time, just pause the video and resume it after you find them. On the list, what are the common multiples of 4 and 6? Yes, it is 12 and 24. Both numbers appear on each list, and you call them common multiples. How about the common multiple of 5 and 6 on the list? As you have guessed it, it is 30. Finding common multiples isn't so bad, isn't it? Now it is time to learn about the least common multiple. I prefer to call this an LCM in abbreviation because it is much easier to pronounce and write in this way. So by definition, the LCM is the smallest common multiple of two or more numbers. Consider finding the LCM of 2 and 3. On the list, there are many common multiples such as 6 and 12. And in fact, if you lay out all the multiples, there would be infinitely many numbers of common multiples. And this is why you find the smallest or the least common multiple. For this case, it is obvious that the LCM is 6. To tell you about one trick how to find the LCM, if you're finding the LCM of prime numbers, which are numbers that only have two factors, including 1 and the number itself, you just need to multiply them and you will get the LCM. So let's apply this example where you're finding the LCM of 2 and 3. If you don't know, prime numbers go like this: 2, 3, 5, 7, 11, and so on. And since 2 and 3 are prime numbers, you multiply 2 and 3 and you get 6, which is the answer we just found using the list. Now before I get into the methods, I just want to review about prime factorization a little bit, because the methods of finding the LCM is purely based on prime factorization. So prime factorization is the process of factoring the original number into its prime factors. Or in other words, you just factor the number until you get all prime numbers. Let's try finding the prime factors of 38. At first, since 38 is an even number, we can divide it by 2. Then we get 19. Is it divisible by any number? No, right? 19 is a prime number, so we stop here. Now we know that 38 is the product of 2 and 19. Usually most numbers are divisible by 2, 3, or 5. As you know, when the number is even, you can divide it by 2. And if it ends with a 5 or a 0, you can divide it by 5. And for 3, if the sum of each digit is divisible by 3, the number itself is divisible by 3. So what I mean by that is, if you say, if you don't know if 33 is divisible by 3, you add the digits and you get 3 plus 3 equals 6. And since 6 is divisible by 3, you conclude that 33 is also divisible by 3. So this division tip might be handy in a lot of situations when you're just calculating in your mind. And knowing this, here's a more challenging question. Again, pause the video and try it yourself. Find the prime factors of 72 and fill in the blanks. Did you find it? At first glance, 72 is an even number, so divide it by 2. Leave the 2 right there, since it's a prime number. Then for 36, you repeat the process. And for 18, repeat the process as well. And you'll get 9, and you divide 9 by 3. And you'll get 3, which is the last prime number. After dividing everything, we just have to count the prime numbers that we got. And the prime factors we got are 2, 2, 2, 3, and 3. So 72 is the product of 2 times 2 times 2 times 3 times 3. Okay, so going back to finding the LCM, let's get into the 2 main methods which I think are the most used and most efficient. They are in fact methods of prime factorization, but we use it for finding the least common multiple. The first way is called factor trees, and it is what we just did. As you divide your number by its prime factor, you set up branches like a spreading root. You can either draw it horizontally or vertically depending on your preference, but usually we draw factor trees vertically. Also, my tree goes kind of zigzag because I had to fit the tree inside the slides. But it's always better to have prime numbers solely on your left or your right, so that it's easy to track them when you're done with factoring. Right now, the trees indicate the solution of the question we just answered. Now you might wonder, how do we get the LCM out of this tree? To do that, we need another tree with a different number. For ease, how about 36 as an example? We already solved for the tree of 36 since it is included in the tree of 72. Here we say, if you lay out the prime factors, you will get this. Do you want to have a guess on what the LCM would be? 72, isn't it? 36 times 2 is 72, and 72 times 1 is 72. So 72 is the least or the smallest common multiple. Now, knowing the answer, let's see how this tree method works. At first, you identify which prime numbers are in those factored lists. For this example, I see only 2 and 3 on the list. Now look for the greatest occurrence of each number you found and multiply that amount. Let me clarify using this example. 2 appears 3 times on 72 and 2 times on 36. So finding the LCM, you multiply 2 3 times. And for 3, it appears 2 times on 72 and 2 times on 36. Since 3 appears 2 times for both numbers, you just multiply 3 2 times. Again, you multiply the amount that most occurs for that very number. So what do you get as a result? 72. That's right. Using the same method, let's try finding the LCM of 8 and 12 this time. If you want to try it by yourself, just pause the video. So first, we need to make factor trees for 8 and 12. And here it is. Extract the prime numbers, and for each one, identify how many times it occurs at most. 2 occurs 3 times on 8, and this occurrence is greater than the number of times it occurs in 12. So the LCM is currently 2 times 2 times 2. And is there any more prime numbers? Yes, there is number 3 left, and it only occurs once in 12, so it is the most occurred instance. And as a result, the LCM becomes 2 times 2 times 2 times 3, which is basically 8 times 3, and the answer is 24. The next method is honestly my favorite, and this is the one I always use when I find the LCM, and it is called a ladder method, also known as the upside down or repeated division. You simply divide the numbers by their common prime factors and move down the ladder. Let me give you a visualization of what it is and how it works. You start from the top, labeling your numbers. So for example, if you need to find the LCM of 45 and 50, you put it like this on the top. Then you start finding the common prime factor of 45 and 50. Technically, you can find any common factor other than a prime number, but usually it's harder to find them, and it's not the case most of the time. Of course, if you can, it quite quickens your calculation by a little bit. After you found out that the common factor is 5, you just divide both numbers and write quotients right below. 9 and 10 are not prime numbers, but you should stop here because there are no more common factors that we can divide these two numbers. What should we do now? You multiply all the numbers that are on the outer side of the ladder, including the 9 and 10. Think of it as drawing an L and multiplying all the numbers that are on the way. So, the LCM of 45 and 50 is 450. This simple technique allows us to combine many steps that we did on the previous method and significantly reduces our calculation time. And by the way, the ladder visualization was just for reference, and it actually looks more like an upside down division like this. Now you might wonder how this works and how can it be so simple to determine the LCM. The trick is, you're doing the exact same thing, except that now you're not factoring those numbers separately, but both at once, reducing the tedious work. So for the first example, let's try finding the LCM of 24 and 36. Pause the video and try it by yourself. Let's put 24 and 36 side by side and divide them using the upside down division. 2 goes for 24 and 36, and you get 12 and 18. 2 goes again and you get 6 and 9. Now 3 goes into 6, 9, and you get the last two prime numbers, which is 2 and 3. As I've said, draw an L and multiply everything on the way. So after you do the calculation, the LCM is equal to 72. This time I'm going to use 3 numbers instead of 2, and you're going to do this following the exact steps that we just did. Find the LCM of 16, 24, and 32. I strongly recommend you to pause the video and try it on paper. First, let's place 16, 24, and 32 upon the upside down division. They're obviously divisible by 2, so let's do it. We get 8, 12, and 16. Again, since they are divisible by 2 as well, we divide them and get 4, 6, and 8. Looks like we can do it one more time, and at last we get 2, 3, and 4. So I would guess that most of you guys have gotten to this point and just multiplied the outer numbers. But if you do that, you will get 192, which is not the LCM. If you see the remaining numbers 2, 3, and 4, 2 and 4 are still divisible by 2. When you're trying this method, make sure that no pair of numbers are any more divisible. I know it may sound confusing, but at the bottom, even if just one pair of numbers are divisible by any common factor, and you just ignore them and multiply, you will not get the LCM, but just a common multiple. Just beware of that, especially when you're trying this method with 3 or more numbers involved. As you can see, since 3 is not divisible by 2, you just leave it out and rewrite the number below. After you do so, you will get 1, 3, and 2 as a result. And the LCM would equal to 96. Now, talking about the applications, the LCM is used to find a common denominator when comparing 2 or more fractions. You will encounter these much often as you take higher levels of mathematics, and by that time, you will be really good at finding the LCM. Another example might be word problems or real-life situations. Let's say there's a track, and John and Jason started their race at 11 o'clock. If Jason takes 4 minutes to complete one cycle, and John takes 10 minutes, at what time will they meet again at the starting point? This is asking you to find the LCM of 4 and 10, and since the LCM is 20 in this case, John and Jason will meet again at 11:20 at the starting point. And having that said, thank you for watching, and in case if you want some additional practice, you can go into Khan Academy where math is fun just to refresh your mind and do some practice problems. And that is all about LCM.